And we're back to finish up chapter 10, where now we're going to show you how we can calculate the molecular formula from the empirical formula. And we're going to do this in 3 examples. So let's go ahead and jump right in. Now, if you remember, the molecular formula shows you the actual numbers of types and numbers of each atom in the compound. So it's giving us the real formula, essentially, is what it's doing. And so it says in this question, determine the molecular formula of a compound with an empirical formula of CH2O and a molar mass of 180 grams per mole. We will always give you the empirical formula and then also give you the molar mass. So now, what do you do with that? Well, the empirical formula is CH2O. And if you calculate the mass of the CH2O, you have 12.01 plus 2 times the 1.008 plus the 16, and that's going to be approximately equal to 30. It's going to be 30 point something. Okay, but let's just stick with 30 for right now. 30 grams per mole. Now that is the mass of this empirical unit. Now the actual formula is going to be some multiple of this. Just like when we went through, and let me scroll all the way up to towards the top here. All the way back, all the way back, all the way back. Here we go, to this particular chart here, where we were determining, we actually gave you the molecular formula, and we backtracked to the empirical formula. We had to divide by a certain number. In this case, for glucose, we divided through by 6. We also divided through by 6 on this one, divided through by 2, divided through by 2. In this case, it was the exact same formula. But the basic idea is that you had to divide through by a certain number to get back to the empirical formula. Now what we're going to do is we're going to take this empirical formula and figure out what number do we multiply it by to get it back to the molecular formula, because that's generally what you're looking for. Alright? So what number are we going to have to multiply this empirical unit by? So let's go ahead and scroll all the way back down to the bottom. Down we go. Here we go. And so it turns out that this has a mass of 30 grams per mole. The real formula has a mass of 180 grams per mole. So the question is, how many of these are going to fit in the real compound? Well, if these weigh 30 and the actual compound weighs 180, 180 divided by 30 gives you 6. There are 6 of these in the real compound, so therefore you have to take your formula and multiply it by 6. And so in this case, we would get C6H12O6. You have 6 times 1 gives us 6, 6 times 2 gives us the 12, and 6 times the last one gives us 6. So it is C6H12O6 in this particular case. We would actually have glucose. Alright, let's go ahead and try another one. Determine the molecular formula of a compound with an empirical formula of CH2 and a molar mass of 56 grams per mole. So the first thing we do is figure out, well, how much does this weigh? Well, you have 12.01 plus 2 times the 1.008 grams per mole, and that's going to give us a mass of 14.03 basically. So that is the mass of the empirical unit. Now, how many of these fit in the real compound? Well, the real compound has a mass of 56 grams per mole. So if you divide that into the 56, you're going to see that it's about 4. It's like 3 point something, but it's essentially 4. And so therefore, there are 4 of these units in the actual compound. So let's go ahead and multiply that CH2 by 4, and what you get is C4H8. C4H8, which I believe is some type of butene compound, is what they would call that. Put a little cloud around it. And so wrapping this thing up, again, if you want to try it on your own before we give you the answer here, feel free. The question says, determine the molecular formula of a compound with an empirical formula of CH4N and a molar mass of 90. So you take your CH4N, the mass of that will be 12.01 plus 4 times the 1.008 plus the 14.01 for the nitrogen. And so 14 and 12 is going to be 26. 26 plus 4 is approximately 30. It's going to be 30 and some change. And if just for kicks, let's just go ahead and show you what the whole thing would look like. So as you multiply all those together and add them up, I'm getting 30.052 as the actual mass of that empirical unit. And when you divide that into the actual molar mass, 90 divided by that is going to be 2.994, which is essentially 3. And so there are 3 of these in the actual compound. So 3 times the CH4N is going to give us C3H12N3. And that would be the actual formula, the molecular formula for that particular compound. So to summarize this section, let me scroll up here. We started by talking about how to determine an empirical formula. The empirical formula is the lowest whole number mole ratio. You simply take the mass percent, change it into grams, change it into moles, take the ratio. Okay? And we did that 4 times. It doesn't matter how many elements you have, you still do the same thing each time. To determine the molecular formula, you take that empirical formula that you just calculated and compare it to the molar mass of the actual compound. You want to see how many of the empirical units you have in the real compound and then multiply it by that. Alright? If you have any questions, feel free to see me in class. We'll be doing several labs concerning this, so you'll actually get to see and do this firsthand. But once again, if you do have any questions, see me in class, and that concludes Chapter 10.